So in this question we have y equal to gx, that's y is a function of x, and we know that function. So we basically just plot y equal to gx, and we know that y is 1 when x is greater than, when x is lesser than 0, 0 when x is in between 0 and 1, 1 minus x when x is between 1 and 2, and it's minus 1 when x is greater than 2. So we also know that for the distribution function of y, it has to be 1 when y is greater than 1, max value, 0 when y is lesser than 1, it's the minimum value. Now to find out the density functions, what we do is at y equal to 1, the probability of y being equal to 1 is the same as the probability of x being less than 0, that's fx0. Probability of y equal to 0 is the probability of x in between 0 and 1, that's fx of 0 minus, fx1 minus fx0. The probability of y being equal to minus 1 is the probability of x being greater than 2, that's 1 minus fx of 2. Also, the probability of y being in between 0 and 1, that's this portion. This is actually over here, we can apply the fundamental theorem, that's fx of x divided by the mod of the differential of the gx function. So from that we get the fx of 1 minus y. Now we know all the values for the density function. So we can say it is 1 minus fx2 into del y plus 1 at y minus 1. We use the del y plus 1 term to actually denote that it exists only at y minus 1. Similarly, we get fx of 1 minus fx0 del y at y equals 0, and in between minus 1 and 0 we have fx of 1 minus y, and then at fx0 we have fx of 0 we have at y equal to 1, so we have that del minus 1 along with it. To get the distribution function, we know that it's 1 when y is greater than 1, it's 0 when y is lesser than minus 1. In between y of 0 and 1, we actually just integrate it from minus infinity to y in terms of alpha, that's the dummy variable. And on solving, we get 1 minus 2 fx0 plus fxy. Similarly, between minus 1 and 0, we do the same thing, just that this time we get from minus 1 to y, and we get f of 1 minus alpha. Now to make our life simple, what we do is we take this 1 minus alpha to be beta, and what that actually does is changes d alpha to minus d beta, we get the minus out, changes limits y to 1 minus y, then minus 1 changes to 2, and we eventually change the limits and we end up with the answer 1 minus fx minus 1 plus fx of 2 minus fx of 1 minus y. So we now know all the values for this distribution function to 0 when y lesser than 1 is 1, 1 when y is greater than 1, 1 minus 2 fx0 plus fx of 5, and 0 and 1 when y is in between them. So we can draw the various graphs. We were given the graph of fx, that's the density function. We can draw for the general distribution function. Also for the density function of y, we can actually draw this because we know that it is equal to fx of 0 at y equal to 1, it is equal to fx of 1 minus fx of 0 at y equal to 0, it is equal to 1 minus fx2 at y equal to minus 1, and in between 0 and 1 it is actually fx, that's the density function of 1 minus y. So that's the graph we get for the density function of y.